Right. Oh, wow, somebody's actually here. Huh. Her button presses in the background. That's my wife gaming next to me. Gotta finish doing this question. I don't know if I guess Jacob was maybe in your class. Maybe another tutor came over if they helped with these problems. Yo. Gosh. Change this. Do you have any update on that, Amy? No? I cannot tell if you're cutting out or if my Wi-Fi is really bad. I have no dropped frames. Sorry, an update on... Yeah, I think I have no drop frames, and my audio appears to be working. So I think that's the... You're in, potentially. Now that somebody else is here, whoever that is could maybe verify. I can hear fine. All right. Did the tutors who came to class help people with things? Oh, I don't know who non-bred lead. Nancy? Oh yeah, probably Nancy. Harder? Nah, you're good. All right. Sick. You gotta love that. Oh yeah, yeah. So I guessed right. You were Nancy. Uh. So yeah, did anybody help you with any of these? I haven't posted solutions to these. I was hoping to work on those here, and then post them if people were interested in these. But if you've seen these, I could something else. Maybe have better handwriting than this is. We didn't have anyone in second period. We just grouped up and tried our best. Okay, okay, so this is probably helpful. I need to send emails to Chris, but I'm gonna miss days. Warn her. But yeah, let me know if there's anything else you want to see. I'm gonna have to improvise some to get some of this stuff. But I was gonna talk about the quiz some. I was gonna talk about this, obviously, and the multiple choice stuff, which I posted today. The multiple choice answers, which hopefully are correct. They are previous year's version, so if I was dumber in previous years, then so. They both inflection points? Yes, they were. The quiz did go really well for some people. Like Nancy got both fives, I think. And we actually foiled Mangus for the first time this year. Will the optimization be on the FRQ or the MC? It will be multiple choice for sure. Multiple choice, sure. It will not be on the free response. The free response will be like the question I am slowly completing on here, because I have to write with my mouse. Feels a little bad. 8. If infinity. And up from row to infinity. I did get some questions from Charlotte. So I can jump into those if I don't get any questions before I finish writing these solutions. Wait, that's 0. Yeah. My absolute maximum on this one. Critical points at -3 and 0, so -1, 0, and 2. That's -1 plus 4 plus. And 2 plugged in gives me -16 minus 32 plus 8. That. -16 minus 30. How did you get answer for 7 in the MCQ? Oh, yeah. I should probably bop over there and do that. Nobody's interested in this. Number 1 on the MC? Sweet. Let's get it. I want to finish this one question I'm doing here. 48, -40. Min was -40, and the max 11. OMG, 6 minutes late, OMG. It's 7:03. I don't know how you're 6 minutes late. Kincaid wants you to go over an optimization problem with area volume, but they can't be right here right now. Okay, word. Okay, so I can go over this question that's optimization with area and volume, and then I don't have to go to the multiple choice thing. How was the operation? It was interesting. I had no pain for like 6 hours, and then lots of pain for the next 30 hours. So that was fun. Yeah, so talking about this question here, since this follows with the area volume sort of questions here, we have a rectangle that's inside of a circle, and depending on the spot you choose, rectangle will have a different area. And so to build the area equation for this thing, you had to know the length of this thing and the height of this thing. But luckily, the height of this thing is the equation given, root 25 minus x squared. And the width of the thing is just the x coordinate that you choose to go over on both sides, on both the negative and positive side. So the area equation was 2x for the base of the rectangle times the height of the rectangle, which is square root of 25 minus x squared. And if you take the derivative of this and set it equal to 0, you get 2 times root 25 minus x squared plus 2x times the derivative of the square root thing, which is kind of a pain in the bottom. 1/2 times 25 minus x squared, the negative 1/2 times negative 2x. And you can like doink out this 2 and the 1/2. Oh, and then this brings up the factoring question that many of you have retaken many times to finish solving this question. Because when you simplify this, you get a negative 2x squared over the square root of 25 minus x squared for the second term in the product rule there, since I had to do the product rule in order to solve this thing. And I guess you didn't actually need to do the factoring here. It would have helped, but you could just add this term to the other side. Whoops, I need to cross it out. 2x squared over the square root of 25 minus x squared equals 2 root 25 minus x squared. And then you could multiply both sides by root 25 minus x squared. That was probably easier than factoring there. and you get this, and this is very, very solvable. 2x squared equals 50 minus 2x squared. You add 2x squared to both sides, and you get 4x squared equals 50. So x is the square root of 12.5. That's some creative simplifying. Hopefully that satisfies an area type question. There was some setup to build the equation, and then the derivative was kind of a pain, and then actually solving for x in that derivative, it took a little bit of time to actually go about solving. I guess that's just the length would be 2 root 12.5, and the height of this thing would be just the square root of 12.5. So the length is this, and the width, or the height, I guess, would be root 12.5. What happened to the concavity in question 2? It changed everywhere. It went up initially, then down, then up again. So they were both inflection points. How many questions are optimization on the tests? 1 or 2? I'm not 100% sure because I haven't written the tests yet because I missed Thursday. No question mark. Oh yeah, to finding the mistake. Yeah, I don't think there's a mistake in this. Could be. Doesn't? Doesn't. Let's see. My derivative is correct. If I factor out, it definitely changes at both -2 and at 0. I'm pretty sure it changes. With -3 plugged in, I get a positive times the negative. Oh, that's a negative. Did I goof that? Oh, no, no, no. That's a positive times a negative. Oh, no. All right, and then with -1 plugged in, we get a positive times positive. Yeah. Okay. I got them all backwards. That's what's up. I knew it changed every time, but yikers. Yeah, those are actually, let's swap a Rooney on those two. Yep. Yep, I agree. Can you also do 8, particularly part C? Yeah, and then, folks, I'm not ignoring you on the multiple choice. I just have to open that document still. So I'm going to pop back over there and open that when I'm done. All right, so, yeah, oh, another area volume 1. Sick. Yeah, let's do 8. So the volume is base times height, x squared h. That was pretty easy. Then it says, okay, determine the volume equation. Sick. Okay, surface area equation is x squared for the base plus 4xh for each of the sides, because each of the sides is x times h. There are 4 of them. And there's no top, so I don't need 2x squared like I did for the cylinder question we had in class. What box dimensions minimize the surface area? So we know it has a volume of 250 cubic inches, so we know 256 over x squared equals h. And you can yoink that up here, and for h, if we do that, we get that, I'm going to warp up here so I have more room, because my handwriting with a mouse is not very good. X squared plus 4x times 256 over x squared. And you can yoink one of these with the one on top there, and just get x squared plus 1024 over x. And then you can take the derivative of that and set it equal to 0 and get 2x minus 1024x to the -2. Taking the derivative of 1024x to the -1 here. And then you just add this to the other side and you get 1024 over x squared equals 2x. So 2x squared equals, darn it, I didn't mean to cross that out again. All right, 2x cubed equals 1024. So 512 equals x cubed. So x equals 8. And once you know x equals 8, then h is just 256 over 64, or 4. So the box dimensions are x equals 8 and h equals that. Then it adds this restriction that the box height can exceed 3 inches. If the optimal height is 4 inches, then the minimum surface area would now have a 3 here instead of a 4, because our minimum happened when the height was at 4. If we can only get to 3, our minimum's now going to happen at 3, because 4 is a low point, and if this is the lowest we can go now, this is still our low point. So all you need to know is that h equals 3, and once you know that, then you just figure out what x is, and x is 256 over 3 square rooted? That would be the value that would make that happen. And that surface area would be what? 256 over 3 times 3? Oh, no, surface area. I'd have to plug into the top equation. Yeah, no, it's some janky awfulness when you plug these dimensions back into that surface area. But that's how you do that. The test is cumulative knowledge, right? Yes. However, it's very, very, very focused on the stuff this unit. The cumulative knowledge part is the, hey, remember the product rule's a thing. Like we had to do in 29 here. Like that's something from last unit. Quotient rule, chain rule, all that stuff is what's cumulative. Could there be a limits question? Yes, absolutely. There will be at least one limits question. Having said that, there will be at least 10 questions where you got to take a derivative and find critical points or something like that. So it's very, very focused on this unit. So that answered. No hard fractions, please. I can't guarantee that, but if there's a hard fraction one, then it's meant to be a hard question that most people get wrong, which, those exist on the tests. Why they're graded nicely. What units are it on again? Mostly this unit, but otherwise every other unit. So I'm gonna pop open the other thing, the multiple choice, so I can talk about the questions that I got on that. Should I open my answers? Should I open the question? Just open the question. And table editing. Cool. And the new stuff is not quiz 3 through 18. Is that true? That's finding critical points through optimization. Yes. I don't know which one. Is NQ2 finding critical points? I know that's the start. It's finding critical points. Whatever that is. Is there a semester final for this class? Yes. Maybe. Probably. Yes. The semester final, by the way, is just going to be a normal test because all of our tests are cumulative. So they all count as final, so there's no like change in routine or whatever. All right, let's start going through questions I got earlier. Let's see. Oh my gosh. Question 1, question 7. That looks like where I'm starting on the multiple choice. Okay, so 1. What value of c on the open interval 0 to 4 satisfies the mean value theorem for f of x equals root 3x plus 4? So first you got to plug 0 and 4 into this. So f of 0 is 2, if I plug in 0 into this function. F of 4 is 4, if you plug in 4 into this function. Sorry, I'm laughing at my wife. She can't figure something out. It's fine. Okay, then you do y2 minus y1 over x2 minus x1, which is 2 over 4, or 1/2. That's your average rate of change. So that's part 1. And you set that equal to the instantaneous rate of change, which is the derivative, which we take the derivative of 1/2 3x plus 4 to the negative 1/2. And then we chain out the 3. Now, oh gosh, why did it not write that? Okay, times 3. Okay, so then you can just divide by 1/2 on both sides, and you get 1 equals 3 over the square root of 3x plus 4. And this is not too bad of an equation to solve. So you get root 3x plus 4 equals 3. You can square both sides and get 9 equals 3x plus 4. Subtract 4 from both sides, 5 equals 3x, and now it's pretty obvious that the answer is x equals 5/3. So that's the value of c, the x value, where the mean value theorem would be satisfied on the interval. So hopefully that helps. Okay, now I'm really confused by chat. Theoretically, if I asked you to bark at your wife, would you do it? Purely theoretical. And then the follow-up question, Amy, question mark, question mark, question mark, help, question mark. I'm just gonna not answer anything regarding that and hope that that's the right play. And no, I'm not a dog. Okay. So, I guess I got a question about 2 on my way to 7 and 12. So, okay, at 2, it's already, it's already, the derivative is already taken. So it says, on what intervals is this thing increasing? So, critical points, like things where stuff happens in this question. -1 for x plus 1, 0 for the x squared, and 1 for the x minus 1 to the 1/3. So if I pick points in between, I could test these. Now, little shortcut, x squared's always positive, so I'm going to ignore that, homie, and just look at these other two. The 1/3 power doesn't change my sign at all. So all I'm going to look at is -1 over -3. That's positive. If I plug in -0.5, 0.5 over -1.5. That's negative. 0.5 plugged in gives me 1.5 over -0.5. That's still negative. And 2 plugged in gives me 3 over 1. Positive. So moral of the story is it's increasing on the edges, not in between. So just had to look at that one. Wouldn't it die since it's in a third root? No, because third roots are actually a-okay. Because like -1 cubed is -1. So we're actually allowed to have negatives in cubed roots. Whereas you can't have them square roots. Because -1 squared is not -1. So, actually chilling with the 1/3 power. Have I gotten my Path of Exile hours in? Yes, I played like 17 hours of Path of Exile this week. Got to 93 in the Challenge League. Had a lot of fun. So definitely did that. All right, where are we going next? 7, I think? Okay, what is the position of the particle when it's farthest to the left? Okay, it's kind of hard to talk about this one without doing the first part of this one, I guess. So I guess I'll just do both of them. 3t squared minus 14t plus 8. And then the acceleration equation is 6t minus 14. I expected more than 17. That's fair. I was in pain a lot of that time, and I had to go to my wife's mom's for her birthday dinner. So, out of the things. Okay, so the way I did 6 in this is speeding up or is an evil type of question because speed is increasing when velocity and acceleration have the same sign, either both positive or both negative. That makes this one decidedly evil. Because you have to actually identify where both of them are positive or negative. So I hope that velocity factors. I'm pretty sure it does. Yeah, it does. So minus 4 and minus 2, like Mia. So we get 2/3 and 4 as our critical points. And this critical point is at 7/3 in the second derivative. And so I just want to figure out where they're negative or positive. So I could test on either side of these and get positive, negative, positive for B. And this one's even easier. It's positive on the right side of 7/3 and negative on the left side of 7/3. So at the beginning, before 2/3, the velocity's positive and the acceleration's negative. So that's no good. Then between 2/3 and 4, my velocity's negative. And until I get to 7/3, my acceleration is also negative. So I know it needs to go from 2/3 to 7/3. That's where they overlap and have the same sign. And then after 7/3, I'm positive. But after my 4, my velocity is positive. So my acceleration and velocity match again after 4. So I'd also have to go from 4 to 10. So this question was evil because it wasn't just asking about acceleration. It wasn't just asking about velocity. It was asking about both. Which means it had to be E. Will there be a question like this on the AP test because pain? Yes. What is the position of the particle when it's farthest to the left? Okay, so what this is asking is for the absolute extrema. So when is it absolutely at its highest or lowest? And so I'm going to go to the velocity graph to analyze this one. Because from my velocity graph, I start off going up, and then I go down until 4, and then I go up at the end until I reach the end. From my velocity chart here. So I know it looks something like this. So my eligible spots where I'm at my highest are at 2/3, whatever the y value is there, and at 5. Or sorry, at 10, whatever my y value is there at the very end of the interval. Wait, no, those are my highest points. I want my lowest points. Never mind. LOL. I want these two. These are my two eligible ones. So that's at 4 and at 0. So I'm going to test 0 and 4. So if I do that, f of 0 is 5. Cool, that's one of my options. And f of my other low point was at 4. If I plug that into my original function, back into x of t, I get 64 minus 7 times 16, plus 8 times 4 plus 5. So what's 7 times 16? It's 96 plus 16, 112. So 64 minus 112 plus 32 plus 5. So that's 101 minus 112. That's negative 11. That's lower than 5. That's my low point. So hopefully that answered the people who asked about 6 and 7. I'm going to go to 9 next. Okay. Yeah, I got double questions for 9. Seems good. Oh, goodness. Okay. So let f be the function like blah, which of the following is the equation for the line tangent to the graph of f at the point where x equals 1. All right, sick. I'm going to plug in 1 and get 2 times 1 to the 5th. Cool. I know 1 comma 2 is a point on my line. Second thing I'm going to do is take the derivative of this. Surprise, this is where the test gets cumulative. We have another product rule. So a prime minus x, like so. Take the derivative of that and then multiply by the derivative of the inside times b plus, oh goodness, I'm not going to have room. Oh no, this one's easy. 2x minus 1 to the 5th times b prime, which is just 1, so I don't need to write anything. And boom, there's f prime of x. I can just plug in 1 now, because this is my slope. And I get 5 times 1 times 2 times 2 plus 1. Okay, that's 21 for my slope, so yoink, get rid of C, D, and E. Those are no longer options. My slope's 21. And then, I know it goes through 1 comma 2, so if I use point slope form, I can just call it y minus 2 equals 21 times x minus 1. And then just add 2 to both sides and get y equals 21x minus 19. That's how I go through it. You don't know point slope form, you can always do y equals 21x plus b, and then plug in 2 for y and 1 for x and solve for b. That is an equivalently good way of solving for the y-intercept and figuring out that the answer is b. A little bit of algebra 1 there. All right, 15. No surprise I got questions about that one, because this is not a question that you're asked to do without a calculator. Reasonably. Now, you could do this without a calculator, but you may notice from the 3 decimals that this is a calculator question, at which point all you do is graph sine of x cubed. I don't remember what it looks like. It's a sine and it goes faster and faster. It looks something like this, and then it goes ham over there. So the maximum happens at like the first spot. Oh wait, it's a sine, so it goes like so the maximum happens right here at the first spot where it goes through 0. You just look at that on a graph. Alternatively, you could set the derivative equal to 0, like mia, and sine is equal to 0. Oh, so you can inverse sine both sides. Sorry, I have said that first. Sine is equal to 0 at 0, but it's also equal to 0 again at 2 pi. Wait, at normal pi? That would be the next spot where it equals 0. So really, the answer we were looking here was for the cubed root of pi. Whichever one of these answers is the cubed root of pi. So if you know that offhand, that could get you there. I think it's this one. So that's the way you could get that. But otherwise, you could just look at the graph and look for the first spot where the derivative switches from positive to negative, because that's a maximum. So that would do it. Hopefully that answers people's questions on 15. Okay, 12. Wait, how did you get started on the y part? I should go back and answer that question for 9. So I use point slope form or slope intercept form to figure out that. Oh, at the beginning, the way I found the y value is just plugging in 1 into f of x. So I got 1 to the 5th times 2, which is just 2. And that allowed me to get this coordinate, which allowed me to build these line equations after I found the slope. Hopefully that answers that question. Happy last night of Hanukkah. Oh yeah, sick. That the good one? No, all the days of Hanukkah are good, right? You get presents at all of them? Yeah, I don't know. Not a resident expert on that. So, okay, if f is the continuous function on the closed interval a, b, which of the following must be true? Okay, sick, we have a continuous function. Which one of these have to be true? The value at some point equals 0. No. There is a number on the interval such that it's in between the beginning and the end. Like, this implies that the end is bigger than the beginning. That's ridiculous. It doesn't need to be. It could be going down. There's a number on the interval such that... Basically, what this is saying is that there's a maximum point on the interval somewhere. Like a high point. That one's reasonable, I think. There's always a high point on an interval, whether or not it's the endpoints or it's the low point. So let's leave that one in the likely good camp. There is a number on the interval such that the derivative equals 0. No, this case disproves that, so that's an inst rule out. And there is a number on the interval where the derivative needs to be equal to the average rate of change. This one seems good, but continuous is not good enough. For this one, for e to be true, we have to be differentiable. So differentiability is required for this, for the mean value theorem for derivatives here. So, wait, I just wanted to write differentiable. So yes, it needs to be differentiable or that thing doesn't work. Differentiable. So we aren't given that. We're just given that it's continuous, so that one's also ruled out. So sure enough, C is the one that must be true. 12. 17, please. The related rates question? No. Alright, the sides of a square are increasing at 5 meters per second, and the radius of a circle is increasing at 2 meters per second. At side equals 5 and r equals 4, which shape's perimeter is increasing faster? Which shape's area is increasing faster? Alright, sick. So 2 pi r is one equation, and side squared is the other equation. So derivative 2 pi dr dt for one, and 2s ds dt the other. And if I plug in 5 for s and 5 for ds dt, I get 50 for the square. And if I plug in 4 and... No, I'm just plugging in 2. I get 6 pi. Yeah, it's pretty obvious which one of these is bigger. I'm going to take the 50. The perimeter of the square is increasing much faster at this moment. So then go to the areas. Wait, did I just mess up? Gosh darn it. That's the wrong equation. That's the area equation. 4s, not 50. I'm going to have to double check this. The derivative is 4 ds dt. Oh, goodness gracious. All right, 4 times 5, 20. 20 bigger than 6 pi? I think we're vindicated. I think 20 is still bigger than 6 pi. Square wins. Then I look at areas, and this is where I'm going to use the side squared homie that I accidentally used before. Oops. 2 pi r dr dt is the derivative of pi r squared, and 2s ds dt is the derivative of s squared. Now I plug in, this is 50, and 2 pi times 4 is 8 pi, times 2 is 16 pi. And I believe 16 pi is bigger than 50, so I think circle wins for area. So circle for the area and square for the perimeter are what I got. Those. Let's see what we got here. Can you do 14x? Wait, how did you get 6 pi? Did I mess up? Is it 4 pi? Is it 2? Yeah. Thank you. How did I get 6 pi? By making it up. It's a 4 pi, so 20 is definitely bigger than 4 pi. However, in the areas, 50 is smaller than 16 pi, because 0.1415 times 16 bigger than 2. Yeah. This is very slightly bigger 16 pi here. And I would never make you answer that without a calculator, because that seems unreasonable. All right. 14. The figure above shows the graph of f prime of x. Oh, the figure below. Yikes. The derivative of the function of f on the open interval -7 to 7. Sick. If f prime of x has set 4 zeros on this interval, how many relative maxima does f have on the interval? Okay, so for a maximum, you have to go from positive to negative slope. So literally only here. There's no other spot where it's a maximum. This spot right here would be a minimum. These spots, this one's also a minimum. And this spot is an inflection point or a saddle point. It isn't a maximum. So maximum, only 1. If it said minimum, it would be 2. If it said relative extrema, there would be 3. So a bunch of different ways you can boil that one down. All right, question 11. So you have 2, 3, and 4 as your points. You just had the test in between these to see which ones it changes at. So 1, 2.5, 3.5, 5 are on either side of those. To get rid of all these pictures. Bottom question. If you plug 1 in, you get okay, this thing's always positive. I'm gonna ignore this, homie. All right, -1 times negative. Okay, that's positive. 2.5 plugged in is positive times negative. Negative. 3.5 plugged in, positive times negative. Negative. 5 plugged in, positive times positive. Positive. So what's true? We got a max at 2, so 1. And we got a min at 4. That's not an option, so it's literally just that first one. There wasn't an option for the other. Did I actually get through all the questions for this? Check. Charlotte also sent me many questions. See if I answered those at some point. 1, 2, 7, 11, 12. Dang, I actually got through Charlotte's list. Sick. So, now that I've slammed through a bunch of these, I was going to talk about the quiz probably next. I can't pull up, but I have in front of me. I don't have the file. That's school. So the quiz, just go here. So I can draw this thing, and it will look beautiful. My drawing skills are immaculate. Yoink. And I believe both classes had the same picture. I think the sub passed out the wrong one in the wrong class, so ran out and had to give some. So even in second period, you may have had the fourth period class one. So in one of the classes, in second period, it asks where is this thing decreasing? And it's decreasing where the y values are negative. So it was from -2 to 2, and from 2 to 4. So a few things to point out about this. First thing, it's not increasing at, or sorry, it's not decreasing at 2. So you had to split it up like this in order to receive full credit on this. Additionally, a lot of people told me, yo, it's also not decreasing at 0, but that's not actually correct. So a lot of people did this sort of thing. This isn't true because at 0, the value is negative. Even though it's like a cusp sort of thing, that would affect the second derivative, but doesn't affect the fact that it is decreasing because the value of the slope is negative at that point. So it had to be an answer that looks something like this one for decreasing. For inflection points, those are maxes and mins. So those happened here at 0. Even though that thing's a cusp, it's still a spot where the second derivative is changing sign, which is the definition of inflection point, and at 2. So the inflection points happened at 0 and at 2. And then the last part in this quiz, the second period one, the one that most people in second period had at least, said at 1 and 3, cut off an interval and find where the mean value theorem is satisfied. Between 1 and 3, the average slope was 0. So the spot where the slope was 0 was at 2. And so x equals 2 was where that was satisfied. Now I'm going to draw another one of these and talk about the other version. Benefit everyone probably, because it just had same picture but different questions. Okay, so the other one asked about concave up. So where's this thing concave up? It's where the graph is increasing. So that was the only spot where this graph is increasing is here from 0 to 2. Then it's asked for the maxes and mins. There was only one of those. There was a max right here, which was at -2. X equals -2 was a max. There was no min in this, because there was nowhere where the slope changed from negative to positive. And then the last part asked about the mean value theorem, same thing as the other one, except from -1 to 4. And roughly the slope looks something like this. And so you had to mark off a spot like here-ish, where the slope looks something like that, which was around 3. So around x equals 3 was the answer that I accepted on that one. And a fair amount of people did get that. That was pretty cool. All right, and then talking about the optimization one, man, almost everybody set up these optimization questions right, because it wasn't too evil of a question. It was very similar to a lot of the other ones we had, but man, did some of you multiply and add wrong. Like, more of you multiplied and added wrong than any other mistake, and than people who got it right, sadly. So the prices were $10 on one version. They went down by 0.1 every time you went over 1. And the number of people in the stadium was 27,000. And that number increased by 300 every time you went over 1. So that was one of the equations, and the other equation was 10 minus 0.2x times 20. No, it wasn't 27,000. It was 15,000 this time. So this is a much worse baseball team than the other question because much fewer fans, many fewer fans. So these were the two equations, but man, did the multiplication go wrong here. In the 27,000 case, you should have, there's an example of somebody who did this right, so I can show what it should have looked like. Use this, students. After multiplying out and everything, you should have gotten like, I can just do it. 27 with 4 zeros. 0.1 times that is minus 2700x. 300x times 10 is plus 3000x. And 300 times 0.1 is minus 30x squared. And then when you combine like terms, all you get is 3000 minus 30x squared. 1000x minus 30x squared, and the 27 70,000. But when you take the derivative, this term goes away. We just get 0 equals 3,000 minus 60x. And if you add 60x to both sides, you end up just getting x equals, I goof this, 300x, gosh darn it, so 600x, so you get x equals 5. And then you were supposed to, a lot of people said like, oh, $5. No, that's not what x equals 5 means. You had to then plug 5 back in here and get 10 minus 0.1 times 5, which is $9.50 is how much they should charge for their for the ticket. That was the reading the word problem type question. Yeah, and regarding the needing calculators thing, those of you who needed calculators generally were the people who turned this into 1,000 minus 10x, which meant the numbers you multiplied were way harder. 0.1 is really easy to multiply by things. I would just keep it like 0.1. It keeps your numbers smaller. It keeps you from making mistakes. The other one, you should have gotten x equals 10, so that other baseball team should have lowered their tickets to $8 in price, because you should have gotten x equals 10 there. Hopefully that answers questions. Are there any other questions? You just gave me a shout out. Did I? Oh. Is it okay if we said the price decreased by $2? Yes. If I didn't accept that, just let me know and I'll fix it, but I think I did. Wait, was there like, there can't be any more than 58,000? Yes. So the other piece of information was that there were 55,000 people capacity of the stadium. And that was pretty irrelevant because if we plug 10 in here, we get to 20,000 people are going to come. And if we plug 5 into this one, we just get an extra 1,500 people. So that's 28,500. So that the endpoints weren't relevant here. They could have been. So Magda, regarding your question, if X had been like, I don't know, 1,000 or something, and it would have pushed us over 10,000, wow. Then we would have just said, yo, whatever number maxes out the number of seats in the stadium, that's how we max it out. So if that had been the case, that's what we would have done. Which is actually, interestingly enough, almost exactly what we did in this question with the height. Because I knew for my minimum height, I wanted it to be 4, but if I can't go higher than 3, then 3 is where my minimum happens, based on how this question works. So very similar type of constraint. Here's where it actually applies. Are we chilling? Is there anything else? My wife's shaking her head. She's saying there is nothing else. Gotta make that test tomorrow or Tuesday. Thanks for showing up. Thanks for hanging out. Hopefully you learned something. Hopefully my handwriting didn't curtail us or like sabotage us too much here. I'll answer any questions in class before the test if you like me to. Shouldn't take the whole period. Isn't the test on Tuesday? Yep. Yeah, the test is on Tuesday, so I have Tuesday to write it if I want. Pretty cool. Oh, this one definitely didn't fit on the graph. No, that's wrong. -3 is a max. Oh no, that was something like Oh, that's a saddle point. That too. Wait, you're back on Tuesday. Oh, yeah. Oh, sorry, folks. I am definitely back. I didn't have my real surgery. I just had the test for my surgery. Yeah. So I have not had my my big one yet. Hopefully the test is positive. I mean, wait. Good. So I'm still at school now. The when I'm taking time off might be January or February probably, or maybe during winter break. I don't know. We'll see. I gotta talk to my doctor, the guy who will cut me, orthopedic surgeon. So yes, I am not gone forever yet. No, no, no. I'll be there Tuesday. Wanted to get rid of me, and you're sad. I'm sorry. Please don't be gone during finals. I will cry. Yeah, I'm still trying to decide how I'd do that. Whatever whatever I do, just trust that I'll be fair with it. I promise. I'm not trying to mess you guys up. I'd actually try pretty hard not to that. Yikes, this thing was omega steep. That's all it shows up as. Wait, would that actually mean no finals? If I miss finals, I'm not gonna make the student teachers like Chelsea and stuff. I'm not gonna make them give a final. So no, I'd probably wait for the final until I got back for the tests. I'm not like married to giving tests. So we love that graph. Yeah, that's a pretty chill graph. It goes up like way fast on either side. Yeah. Anyways, on that note, I think I am out of questions. I'm still here. If Chelsea's in fourth, it just means she can get used to the class and meet all you guys in fourth before I actually miss time. So that's good too. Yeah. Anyways, yeah, adios. I'm gonna sign off here. Hasta la vista. See you on tomorrow or Tuesday.